Hello, good afternoon, everyone, and welcome to another Big Data London webinar. Today's another one in our Technology Modernisation series, and we're looking at simplifying the single view. I'm Andy Steed, Content Director of Big Data London, and I'm joined today by Oliver Bowie from Triangle. Hi, Oliver.
Hi, Andy.
And Charles Southwood. Hi, Charles.
Hi there.
And Chris Fitzpatrick. Hello.
Andy, hello.
And Charles and Chris are both from data virtualization experts, Denodo. So these sessions are designed to be interactive, so please send in your questions throughout the presentations, and I'll endeavour to ask as many as I possibly can at the end of the sessions when we've got a little bit of time dedicated to Q&A. Just a quick housekeeping note, if you lose the video stream at any point, you shouldn't, but if you do, just hit refresh in your browser and you'll jump straight back in. However, without further ado, I'd like to pass on to our first presenter. So over to you, Oliver.
Thanks so much, Andy, and it's a real pleasure to be speaking to you all today, so thanks for joining. And specifically, I wanted to kick off today's webinar with a story. So over 4,200 years ago, a certain group of people found themselves in the land of Babylonia. It was a beautiful place with large open spaces, vast plains, and enough space for people to settle down and start their lives. The people that lived in Babylonia all spoke the same language and were united in building a great town for themselves. And Nimrod, the king of this land, had a big dream. He wanted to become known as the greatest king of the whole world. His vision was for Babylonia to become famous all over the land and for himself to become known as the most powerful king of all. And to prove this, King Nimrod wanted a symbol that he could show to everybody. So King Nimrod's minister said that they should build a tower in the center of their land, and so tall that it touches the sky. And he believed that people from all over the world would travel to come and see it. And it would remind them that King Nimrod was the most powerful king ever for ages and ages to come. The king sent out an order to build the tower at the earliest, and so work on the tower began. And Nimrod, the king's man, Nimrod's minister ordered thousands and thousands of people to instruct them to start work on the tower and to help them with the build. And what that meant was that every single person from Babylonia was ordered effectively to start work immediately. But ultimately, the progress on building the tower was slow. The king's ministers wanted the workers to continue throughout the night and do whatever it took to complete the tower in the time set by the king. And so what happened was, God was looking down on the way that people were working, and ultimately, especially how the king was making Babylonia a great place. But ultimately, God felt angry and sad. He saw that King Nimrod was consumed by greed and pride and had only selfish thoughts about making himself great and powerful. So God saw that the king and his people were achieving this because they all spoke the same language. So therefore, what God decided to do was to make the people of Babylonia speak different languages so that they didn't understand each other. And this would stop them from performing this act of pride. So the next morning, everybody was speaking different languages. Nobody could understand what anybody was saying. The workers couldn't understand the supervisors, and the supervisors couldn't understand the ministers. And so God put an end to the king's selfish plans to build the Tower of Babel. And so the people of Babylonia stopped work immediately. In essence, what happened, therefore, was that the people of Babylonia were suddenly unable to communicate as they now spoke multiple different languages. And as punishment for their pride, the tower was never completed. As we fast forward to the world that we live in today, we might not be building the Tower of Babel, our own Tower of Babel, but actually what we are doing is building our own businesses, trying to improve efficiencies and reduce unnecessary costs. And as such, we meet regularly, perhaps as part of a team, to discuss some of the most important issues and opportunities facing our organizations. So for example, in the retail industry, we need to know how much inventory we have, where it's stored, and how much it's valued at. In the construction industry, we need to know what the risks are facing our business, when they're likely to arise, what the consequences of no action are. And across multiple different industries, we need to know who our customers are, when and where they're most likely to shop, and actually how the experience we deliver can be improved like never before. When we come together to debate these types of challenges and opportunities, we quickly realize that we aren't necessarily speaking the same language. We understand the words coming from each other's lips, but there's an underlying problem with the foundations of our conversation and discussions. And those are foundations that are ultimately built using data. And so as a result, during this type of debate and discussion, we often spend more time debating whose data is correct, rather than spending the time productively deciding on the best course of action to take to address the company's next phase of growth, for example. And so, as Brent Dyke said in a recent Forbes article, rather than our decisions being informed by data, they are instead paralyzed by data. And that's because of the sheer number of data silos that exist in businesses today that are ultimately creating what we would class as a Tower of Babel syndrome. And as a result, in the same way that work on the Tower of Babel ground to a halt, teams cannot build their businesses because they don't share the same data language. So therefore, to overcome the Tower of Babel challenge, we need to address the influx of data silos. We need to consolidate the different data languages being spoken, and ultimately we need to ensure that the right data is delivered to decision makers. But perhaps crucially, we need to simplify single view. So to explain exactly what that means for your business, the steps you can take, and the outcomes you can expect to achieve, I'm delighted to hand over to Charles Southwood from Denodo.
Thank you, Oliver. Yes, and I think it's true to say that certainly in the world of data virtualization, where Denodo operates, it is probably one of the most common use cases that we see. There are others, and I can touch on those in the next 15 or 20 minutes. Just by way, though, of introducing Denodo, because I think maybe there are some of you in the audience who are not aware of our role. If you haven't looked at data virtualization before, then you probably won't have come across Denodo, because we are a pure play, as Gartner like to call the vendors, in specifically targeting one area of the market. And that's where Denodo sits. We've been operating in the data virtualization world since 1999. And many organizations and individuals look upon us as being effectively the founding fathers of data virtualization technology. Just to very quickly sum up, we are based in Palo Alto, privately owned organization. We are spread geographically across the world. And as you can gather from our work with Triangle, partners are very important to us. And that's partly because the rate of growth that we've seen, particularly in the last 5 to 6 years, I suppose, where organizations have hit the sorts of challenges that many of you are now looking at around things like single source of truth and other data insights. And that has led to accelerated growth, over 50% annual growth. And therefore, the partners are very important to us to support that level of growth, so that we can do it both organically and through partnerships. You can see here over 800 customers, growing very quickly, but they cover pretty much every market sector and industry that you can think of. So there will be people in your own industry who are using Denodo's data virtualization. I've got a couple of quick examples I can give you at the end, just to give you a flavor, obviously focusing on single source of the truth. So what are people doing at the moment? There is a complexity in most organizations' environments, and when companies come to talk to us about their challenges, this is typically what they describe: a number of different silos, multiple data sources, increasing complexity as they move perhaps some of them to the cloud, some of them are now software as a service. They've got a multitude of different data consumers, different BI tools, reporting, data science, analytics, and also lots of different applications, mobile, web services, and various others that they may want to connect to. And a level of complexity that is only increased by the sheer volume of data. And you've probably seen quotes, I think it was Gartner who said that half the data on the planet was created in the last 2 years. And if you look at web activity, social media, Internet of Things, and telemetrics, and you start adding all of those things up, you can see where that comes from. That includes my daughter's many pictures and videos which accumulate on the web. So if we start to look at the way in which organizations are currently trying to address these sorts of issues, there are an infinite number of combinations of architectures, but I thought it quite useful to share with you some of the common ones that we see. The first of them will be perhaps the most frequently used, and that is the idea of taking data from lots of sources, moving it and copying it to some form of centralized store, whether that be an operational data store, a data lake, an enterprise data warehouse. Different companies I find have got a variety of names, but then from there they either give direct access to the users, as you can see in the top option 1, or they have a multitude of data marts that come off that centralized service as well. The lorry obviously being the analogy for the batch process that takes place typically overnight to move the information from one location to the other. So that's one method of doing that, and I'll come on to talk a little bit more about some of the challenges. But clearly, if that involves moving and storing multiple copies of data, there's some questions about efficiencies, and likewise the batch nature of it gives an issue around the timeliness of the data, and we'll touch on that. The second is more for the ad hoc users. The requirement for them to be able to investigate the different data sources that they might have across the enterprise and look for additional value, or look for trends or patterns that perhaps haven't been perceived, requires that these users access multiple sources themselves. And again, I'll come on to the challenges that they face, but typically it's around the complexities of gaining access, the performance issues with doing that when you're dragging large amounts of data across the network, and of course the lack of governance and security you have when you have large numbers of analysts, ad hoc queries, data scientists wanting to query many of your sources. And the third, which is where we're clearly going to be spending most of our time, is the users connecting to a data virtualization solution, and that does all the heavy lifting in terms of the connectivity to the sources and a lot more besides. But you get the best of both worlds with not moving the data, leaving it at source, and also having a single point of entry to make it nice and simple, so that people don't have to worry about the location, the format, the protocol, etc. And that also then addresses things like governance issues and so forth. So we'll touch a little bit on that as well. But what does the business want from these architectures, and what are the common objectives of the business? So if we just look at the three that we see probably most frequently, the first is having this concept of a single entry point, and this is really pertinent to what we're discussing here with single view of the truth. The users wanting to be able to go to one place, a curated data source that has everything that they can possibly want to access, whether that be for your standard reports or whether it be for the ad hoc work that the analysts and data scientists want to do. The second is they want to be able to do it themselves. They don't want the reliance on IT. They want to be able to get the information as and when they want it. As you'll appreciate, and TDWI have quoted that it can take up to 2 months to create new dashboards in a typical enterprise. This is obviously not very timely, and therefore it means that a lot of businesses, when they have requirements that perhaps need to be addressed in a few days, if IT isn't going to be able to address them in that kind of time frame, there's no point in even asking for those. So opportunities get missed by the business because of the speed and the lack of agility with which the IT can respond to the needs of the business. And the last, which is very important with GDPR and GRC and various other regulations, POPI in South Africa and so on, the challenges of security and governance, the ability to provide a uniform security policy when you've got a huge variety and growing complexity of different data sources across the enterprise. So if we consider each one of these in turn, and the different three architectures that I touched on, the first one was about moving data into data marts and data stores and so on. Well, Gartner have done their own work on this, and they estimate that data lake projects, 80% of them are likely to fail to deliver what's required. And you know, the consistency, I think, is in moving and storing data multiple times. It comes with costs. There's also the complexity of the ETL processes, the extract, transform, and load that takes place. And you end up with multiple copies, and that's probably for single view of the truth. That's probably the key issue, because you end up with curated versions of the truth, which are at different velocities and have gone through different data models. And you end up with 4 people around the table with 5 answers to the same problem. And that can lead to shadow IT, which you'll maybe be familiar with in your own organization or you've seen elsewhere, and the variety of copies around the organizations, sometimes up to 5, 6, or even 7 copies perhaps of different versions of the same information. The other is that dependency on IT, which means that the self-service is very difficult to organize. And that too brings with it its challenges. If we then turn to the second one, and I've put up here some examples of the sorts of questions that we see most commonly from customers, typically from data analysts, business analysts, data scientists, the connection complexity. How do they know where the data is? How can they get access to it? There's different formats and protocols that are needed. It's complex and they need help in many cases. The other is the vendor lock-in. If you've got people using tools and the semantic model has been built in that one tool, and somebody wants to use a different tool because it's more appropriate for their own needs, then the entire semantic model would have to be recreated in that second platform. So it's an inhibitor to people being able to switch from one vendor to another. And for the same reason, the collaboration is very difficult between different platforms. Much better to put the semantic model or the data model in a centralized place where different BI tools can access, and that's where data virtualization will come in. The third is performance, because you're going to be dragging large amounts of data across the network, and you do very little or no query pushdown, which we'll touch on a little bit later. And Chris, my colleague, can perhaps talk a little bit more about how that works. That really is key to the way that this that data virtualization operates, and it's a big fundamental difference between perhaps the early days of data federation tools and what you can do with a truly enterprise scale data virtualization tool like Denodo. The other is the poor efficiency. You'll be aware, if you talk to most data scientists in your organization, that they can often spend 70 or 80% of their time gathering the data. And if that can be reduced so that they're spending perhaps 10% of their time gathering data, then that will make a huge difference to the overall performance. And data governance, which I've already touched on, and that's an issue as well if you're going to be connecting directly to the sources. So that then brings us on to data virtualization. Why would you look at data virtualization as part of your strategy? Because you're putting an extra layer inside your infrastructure. Surely that's bringing with it some burdens. Well, Gartner have done their own research on this, and they estimate that 60% of all organizations will implement some form of data virtualization by 2022. And certainly I think the pattern of adoption that we're seeing would reflect that very much. And one of the key benefits of that is the agility with which you can now operate data insights, but also from the point of view of IT costs, Gartner estimated 40% reduction overall in the cost of managing your data integration. And given that you're still doing some ETL and service bus type technology in most organizations, the actual savings in the components that are working now through data virtualization are very high, and we get quoted 80–90% in some cases, depending on the use case. So it's got a lot of value to the business as well. So let's take a look at data virtualization itself. What is it and how does it operate? The first is the 6 points here: data abstraction, being able to gather the data from any format or location. The semantic and logical model is shared in the central platform that you can see here in red. The data sources are on the bottom, the various blocks of different shapes and sizes, and you have the consumers on the top here. Some of them are informational services, which is what we're talking about here with the single view of the truth, and some might be applications that are consuming the virtual layer. The second is zero replication. So it's really important that, unlike a normal data warehouse that you'll be familiar with, which moves and copies the data, data virtualization leaves the data at source. It only abstracts it, transforms it on the fly, combining it with other sources, and passes it to the users as and when the demands are made of it by the consumer. So it's largely a pull type model. You can do push with JMS queues and so on, but predominantly it's the query being pushed down to the virtual layer, and then that brings the data back, combines it, and passes it back. There's a lot more to that to do with the query push down as well, which Chris can perhaps touch on. The third is the real-time nature of it, because some of the applications that may want to consume this may want real-time data. So it's important to mention that one of the data sources people will often have here is the data warehouse. So having said that, you can use data virtualization to gain insights, that's not to say it's a replacement for your ETL data warehouse. It's complementary. But there are some things that may be being done at the moment through an enterprise data warehouse that could be done better through data virtualization. If you've got, for example, something like Salesforce, where it's going to be changing real time as people do various updates, you will still need to take those snapshots at the end of the week, the month, the quarter, to store that in your data warehouse, because the data virtualization doesn't store any data. The data is left at source. So you still need that for historic and trending purposes. But then what you might do is have that data warehouse as part of this lower level of blue here as a source, so that you could then, as a user, you could get an insight that said, I'd like to look at my real-time situation and I'd like to compare that with historic patterns to see how we're performing against the previous quarter, year, etc. So it's very much a complementary tool, but many of the things that you may be doing now to put data in a single source just for a single view of the truth could perhaps a lot easier be done through data virtualization and give you a lot more agility and speed of change and so on. The fourth is the self-service data services, really important. Agile BI and self-service is a requirement that comes up from most customers, I would say. Being able to access the virtual layer with any tool, any protocol, through data services, REST, APIs, etc., is a very powerful way of giving everybody access to the same information, but through a secure and regulated, governed virtual layer. The fifth one, the unified metadata, is important. We talked briefly earlier about the vendor lock-in that you might get from putting semantic models in BI tools. This obviates that problem because the model can be created in the virtual layer and then shared with consumers. So if you have people using Tableau, Power BI, the SAS Institute products, or any other technologies on top, or even RESTful APIs for XML, JSON, HTML, all of those can come off the same virtual layer. So you can imagine it also means, let's say your single view of the truth was a new omni service that you were launching to the market, and you wanted to expose it for mobile, for a web service, to a web page, perhaps HTML, maybe to a dashboard, maybe to a call center, maybe to management reports, all different technologies. You don't have to create that model more than once. It all comes off the virtual layer. So that saves an enormous amount of time for most companies. And certainly when I hear organizations talking about their use of Denodo, the word I always hear, always, is agility. It's the one single gain that is absolutely a game changer to most organizations. The last of these is number 6, the cloud hybrid. Clearly, one of the challenges for many organizations is that many of their data sources are now in the cloud, either through software as a service or in one or multiple of the various clouds, including people like the Azure and AWS and Google and so on. And so that brings with it challenges. But again, the virtual layer means that you can accelerate the cloud migration, and you can also allow multiple locations to look like one environment. So if you've got multi-cloud, on-prem, external sources, all of them can look like a single data warehouse, but it's a logical data warehouse, not a physical one. The data is still sitting at source. So what about your ad hoc users? Well, there's a component inside the platform that allows for them to do just what you would expect. They can explore the different data sets. They can understand the lineage of the data. They can look not just at the governance and the transformations that are defined in the layer, which incidentally are going to be 100% accurate because they're coming directly off the execution engine, which I believe is unique to the platform in any technology. It's not a library of what the governance should look like and what the metadata models should look like. It's actually coming directly off the execution engine. So it gives you a very good image of exactly what's happening in the production system. But it allows your ad hoc users to explore, to query, all through a secure governed layer, of course, but it means that they can look at new insights, and if they see something that's of value, they can have that productionized in the platform for use by the general business owners. So it makes a huge difference to their own work. So in a nutshell, those are some of the key elements. We're talking here specifically about single view, so I don't want to go too much off-piste, but it is worth mentioning that that is effectively the logical data warehouse, which I've shown here in the grey in the top left corner. But it encompasses both the productionized requirements that you might have for reports and dashboards, but also, as I've just shown with the data catalog, the self-service and BI. But you can see here also we can attach to machine learning and AI tools and various data services. We can also attach to other consumers that might be needed for applications and so on. So it has a very wide range of applications, and coupled with that, it addresses the sort of requirements that you often see from IT around security, access, audit, governance, and so on. So just giving you a couple of examples before I pass on to Chris, I thought it worth showing you perhaps two different industries. The first of those is a large multinational telecoms organization. Just to give you a very brief overview of their environment, they wanted to be able to combine different systems for CRM, incident management. This is the call operators that are receiving customer services calls from the telco customers. They've got to attach to network management systems, diagnostic systems, all sorts of complexities. And they were using traditionally what we probably call in the industry the swivel chair integration, where they're moving between different screens or different applications to be able to combine data and find the insights that they need from the different applications. It came with a number of challenges, but what they really wanted was to have a single view, a single pane of glass, as they called it, and that's where they brought the Denodo platform in. All the different data sources could be aggregated through a single virtual layer, and that could be exposed on a single screen. That had a huge benefit to them in terms of reducing the customer call times, because with several hundred call center representatives, they were able to reduce their customer call times by 10%, which is significant in itself. But they were also able to increase their FCR, their first call resolution, which is a very important metric to call centers. And they improved that by 5 percentage points, from 85 to over 90% call resolution. The biggest benefit that I believe they got overall was not just the real-time benefits there, but the fact that by using the agents to do the work real-time on the screens, they were able to substantially reduce the back office work, or the clear up that was needed after the call, by 50%. And that, of course, had, again, when you've got several hundred call operators, huge value to the business. So very clear savings, if you like. The second is a reinsurance company, one of the largest reinsurance companies in the world, based in Switzerland. Some of you may have an idea of which company that might be, but they have a requirement, or had a requirement, for a 360-degree view of the business. And it was a view that came in multiple facets. They wanted to be able to look at the different claims. They wanted to look at, certainly the same as the telco, they wanted to look at customers. They wanted to look at product single views, processing of underwriting and claims and reinsurance policies, and risk and various other operational and back office systems. And the complexity of their environment, which you might appreciate is significant, meant that led them to installing Denodo for that purpose. And that allowed them then to aggregate the clients, the portfolios, the market claims, the cases and processes, the risk views, all of these things, and much of the back office, so they had single view. So enormously powerful. So in summary, it's using data virtualization, very, very powerful tool for bringing things together. It doesn't involve a storing in the virtual layer. It's moved at the time of the query, and it's a highly performant system that I would, if you haven't already looked at data virtualization, why wouldn't you? I would strongly recommend. And with that, if I may, I'd like to pass over to Chris, who's also from Denodo, one of our sales engineers, who can go into some more technical detail for you and show you a little bit of the product. If I could pass across to you, Chris.
Thanks, Charles. Just finding my share button, and I think we're there. As soon as I get my... There we go. So let's hide that. So as Charles has just been through, the thing about Denodo is it's quite a wide-ranging product. Data virtualization doesn't really do it the justice that it deserves. So my background is I worked at Click for 9 years, and that BI background taught me a lot of things about data sources. And really, the big picture that came out was the struggles that all the BI tools suffer from. What I want to show you here is based on a single view, so bringing together disparate data sources, data types, locations, and things like that, and then show you what the approach would be from a Denodo perspective, but compare it to how that would traditionally be done. So what we have here is 4 fairly straightforward data sources. We've got Oracle Enterprise Data Warehouse storing our CRM data. We've also got some CRM data in SQL Server, which is being migrated across to Oracle. So we want to try and combine those. We've also got some demographic data, which is sitting in Oracle as well. We're going to combine. We've got some accounts data, and as all good accounts departments, it's in Excel format. And we've got a company credit ratings source as well. That's in the cloud, so that's coming across as a JSON data format via a RESTful API. So 3, if not 4, very different data sources. And what we're going to try and achieve is this Nirvana single view. Now, in a data warehouse world, the approach would be to extract all this data, stage it into a data warehouse, and then present that out to the users. And data warehouses, there are some good things about data warehouses. So when we talk about a virtual data warehouse or a logical data warehouse, what we're trying to do is present all those great benefits that a physical data warehouse, or actually a data lake with some governance over the top, provides, without all the downsides of that physicality as well. And the 3 big things really are where is the data located? Because these days, there's always going to be data that we're not completely in control of. There's always data sources that are external and difficult to get to. So maybe it's Salesforce data, or maybe it's tweets coming from our customers. We've got no direct access to those, so they give us a friendly API or not so friendly API. And then we've got to somehow reconcile that data with our structured data. Connection types, of course, for every BI tool, for every data consumer, we've got to think about how are we connecting to these data sources. So Oracle could be an ODBC, accounts could be OLE, the Acme company credit ratings is RESTful, it could be streaming data, it could be multi-dimensional cube data. There's lots of different ways of getting this stuff. And we've got to do that for every consuming tool I've got. And it's rare these days that an organization has a single BI tool. They might have a standard, but there will be pockets of people doing the same things and the same dashboards in different ways. So we've got to maintain the connections. And of course, the data types. So 2 date fields in even 2 tables in the same system. But if I'm trying to get my Excel to talk to Oracle, then almost certainly the date fields is going to cause problems. So an example here, we could have trying to answer a very simple, seemingly simple question from the business, which is how are our marketing campaigns driving our sales? That's a very straightforward question, and the smiley face at the end to make sure it happens quickly. And naively, the traditional approach from a data warehouse approach or a BI tool approach would be to, let's say we have these 4 data sources here, would be to extract the data and then join the data and then do that recursively until I've got all of my data in one place, and then do some kind of aggregation. Because that, or group by that, and that would be the approach, because we don't know the answer until we've got all the data, which is logical. But what Denodo is doing here is saying, well, instead of doing this in this order, why don't we we can optimize this process? Because that's the naive logical approach of I want to join, and then group. Actually, there might be a smarter way of doing it. So let's look at the answer we're trying to get to by rephrasing the question. That's what Denodo is very good at. Charles has touched on a lot of these. I'm not going to run through these now, but these are the most salient optimizations that we've got inside Denodo. So all of these are turned on by default. The approach of Denodo is to make it as graphical as possible. So don't expect any scripting or of any kind to go on by default. It doesn't mean we can't. If we've got some DBAs that really know their eggs, then let's let them loose on this stuff, and we can optimize it further. But the optimizations work really well out of the box. I can go in here and don't think of it as a black box or a red box as Denodo is. We can go in there and we can tweak with the best of them, so we can really define what we're trying to get to, because I know my data and clearly a piece of software doesn't. So let's try and optimize it further. But it will apply these optimizations at the point of query. So just like other tools have query plans, Denodo has a query plan for all of the data, regardless of where it sits, and it will then formulate a number of alternatives around that base query plan, and then apply the best one that makes sense at this point in time, because situations change. So that's a list of optimizations. And a question, I don't want to get too technical here, but it's one of the big pluses for Denodo is this ability to reorder that question, to restructure the question. So one of the big questions we get is, well, if I've got 10 million records in my SQL database, how are you extracting 10 million records faster than another tool? And the answer is, well, we're not, because we're not extracting 10 million records, because we don't need all 10 million records, or maybe we don't need the 10 million records at the granularity that original question was asking for. So we're going to look at the question to understand what's actually required to answer. So instead of moving those 3 million rows around in my previous example, maybe we only get a few hundred rows or 1,000 rows, because we're going to do the aggregation at a different level. So in this example here, we could join and group. That would be the naive strategy on the left. The middle one could be, well, I'm going to do the join the group, but I'm going to push that down into a temporary table. So because the customer table is very small compared to the sales table, for instance. But the optimal approach here would be to do this aggregation push down. And SQL Server has the ability to push down aggregation wise, as do other systems. But what we're doing in Denodo is saying it doesn't matter where the data is at the moment or which system you want to push down the aggregation to, because actually we've got that freedom of choice. So if your data is in Excel and it's online and it's streamed and we've got cube data and we've got traditional EDW data, then we can decide which system that gets pushed down to. So it could be delegate it down to a Hadoop cluster, for instance, because that's got the capability of taking that, aggregating it, and spitting back the answer much, much faster in parallel. So that's where the real sort of performance advantages come. So what we're going to do here is connect to SQL Server, Oracle, Excel, and my Acme data source. I'm going to build some base views. Base views are non-transformed, equivalent really of a SQL view. So it's a view that hasn't been transformed. I've not done anything to it. It's just the meta structure of the table. There's no data in it, just the metadata. We're then going to build a derived view. So we're going to model those base views for the CRM data to create like a submodel. Combine it with the Excel, combine it with the credit rating service, and then finally publish it via a built-in web container in Denodo via REST, so then people can consume. So it's connect, combine, and consume. So what we'll do is jump into here. So this is Denodo 8. This is in the final stages of beta. I was tempted to show you Denodo 7, but I'm going to show you the exciting world of Denodo 8. So the Design Studio is it's a web front end. And it's talking to the Denodo server in the background. And on the left-hand side here, we have it's really up to me how I organize this. There's no compulsion here to follow a particular process, but I've split it into different projects. So I have a big data project, I've got a COVID-19 project, and I've got a single view project. And the advantages of splitting into project basis, or could be by department or function, is that I can apply that single security model that Charles mentioned to to restrict people's access and also decide what they get to see if they've got access to the data. So I can control that from that central model. So if we have a look at single view project, so I've split it into sources, views, and then ultimately the web service here. And I've created some websites. So to save time, I've created some folders here. So I've got my company ratings connector. So this is just the underlying connector to the underlying sources. There's no views going on here at the moment. This is just the connector. Connected to Oracle, connected to SQL, and a connector to Excel. And if we have a look at these briefly, so my Oracle here would be using JDBC, and it's using a particular interface to Oracle 11G. These are the out-of-the-box connectors. It's not an exhaustive list. There is a whole world of connectors waiting for you on Denodo's website, but it's a quick way of getting in to an underlying data system. So the JSON connector here via REST would be a different interface, but it's a different wizard. From here, we can create base views. So I could go in here and create a base view, select the schema, select the tables, and say I want to build some base views, which is what I've done in the next step on the left here. So that's the sources. Base views is my accounts. That's the actual meta of the accounts. There's the structure of the data, the underlying data. I've got my company rating, and of course my CRM. So my two Oracle sources, my demographics and my customer address lookup, and my SQL CRM customer as well. So that's sources and base views. What I've also done is built my first derived view. So I've built one that's the CRM data. Now I can expose any of these views, so at any level. So any base view, submodels, those derived views, any of the final stages, and anything in between. So if I was a data scientist, I had requirements for data scientists to connect to Denodo and play with the data in a scientific way. Then I could expose all the base views because they know what they're doing and I trust them. So I'm going to allow them access to those base views and they can build their own models and play with the data. And in fact, Denodo 8 has a Zeppelin notebook built in as well. So I can do that really easily. However, if it's power users or maybe it's less technically focused business users, then I can say, well, I only want you to get to the final output because you're going to connect Excel or your BI tool to connect to this and consume it as is. So I've created a derived view. So we have a look at that. Let's clear these tabs. This final view. So this is the final view here. These are the fields. One thing that Denodo is doing is normalizing the data types as well. So if I'm connecting to Oracle and Excel and a Kafka stream, then those data types could be and probably are very different. So and the fact that a field type might be a char or a varchar or a string or a text, and I expect there are other ones out there as well. Actually, it's just text. So what Denodo is doing is, from a modeling, from a logical perspective, is saying, well, actually, it's all just text. So let's just call it text. Okay. So it could be that the underlying type for C birth country here, this customer birth country, could have been a string or a varchar. Denodo said, well, it's just text, because actually that makes the modeling a lot easier, and we're not losing anything by doing that. So let's normalize the data types. So if we have a look at this, we can see that what I've done here is dragged across 3 tables. So this is my model. I've built out my base views. So I've gone and dragged my base views across here. So my CRM customers, that's my SQL table, or my SQL view, my demographics view, and my customer address view. And that's the model that I built here. It's based on ANSI SQL, Denodo. So it means we have standard SQL things like join conditions, where conditions, having, group bys, etc. So standard ANSI, which means I can script. So if I really wanted to script, I can go for it, or I can just let Denodo do the work for me. If we have a look at the output, so this is the output of the model. So I'm going to join those 3 tables together. This is the output. It's not all the fields. I've already said, well, I don't want all of the fields, so I've removed the ones that are extraneous and are not going to be used. I can also create fields. So here we've got salutation, first name, last name. We could say, well, I want to, I'm actually going to show you some scripting just to show you that it does exist. So I can concatenate the, let's say, the salutation and a space and the first name. So we take the first name and a space, and then we're going to put in the last name like that. So we're going to create that field, because unless I've got a desire to analyze all the people called Mary or everybody who's got Sir at the beginning, so I could leave that information in. But I'm going to create this field, and again, it could be anything. It's a very simple example, but I could be creating anything. So and I could say, well, I don't need the first name, last name, and salutation anymore because it's all in the same field. So I'm saving space and complexity. So we could remove those fields and then save that. So I've now got those combined fields. And if we run that, what it's going to do, and if I execute it here, what it's going to do, and it's come back already, is it's taking the question, which is give me everything from this view. The view consists of these fields, which come from those tables, which are two joins and a creation of a field. And it's going to come back. So go back to those data sources, ask for the relevant information in the right way, the most performant way, most optimized way, and bring it back in the format that I want. And you can see here that it's standard ANSI with a bit of Denodo context on the end. So what we want to do here, so we've built a CRM model. What I want to do is combine that with accounts. Now, what I could do is say, well, I've got my model here. What I could do is add my accounts table. So I could go up here and drag accounts on and then join that. But that's going to restrict my use of this going forwards, because actually there could be a requirement for, I want this data, the CRM bit, but I don't want the accounts. So I'm going to have to create another one. So it's much better to be able to keep this as a building block. So if we take this one out, keep this as it is, and then create a new join. So we can do that simply right click. I want a new join, but using that final view, the combination of the three tables, as the starting point. Yeah. What I want to do is combine it with accounts. The problem we've got is, if we have a quick look at accounts, is that accounts has account name here, and the output of this model is actually an ID. Which is no good. I can't map an ID to a name. Regardless of how good Denodo is, it's not going to meet that leap of faith. So I went to my IT department and they worked all night to produce a lookup table. So what I've got is get rid of that one. So there's the output of my model here. I want to combine this with a lookup table. So there's my accounts table that I want to join. And I have a lookup table. So there's my lookup table. So I can now join that table with that table to say, well, the company is the company, and the account name is the account name, and that's it. So it's going to do that join, but using this lookup as that linking table, that bridging table. A red triangle is never a good thing in anything. What it's telling me is, because I've gone and joined it, because I've not said which fields I want, I've got duplication. Because I've added these two fields which already exist in the data sources. So I could say, well, I don't need them as the output. I'm going to use them as the lookup, but I don't need them. I don't want to select star off this lot. So I'm going to remove those two fields. I'm going to save it, and we're going to call this single view, because it's that's what we're doing. So I've now joined my CRM SQL to Oracle sources and my accounts and save that as a single view. I want to combine that now with my credit rating information. So this is my use case. So I'm going to stick with this model. I'm not going to go create another one, but I'm going to combine this with my credit rating information. The company credit rating has something unfortunate about it, in that there's the company IDs and there's a rating, and that's great. And also, this is a This is a JSON source that's coming in. They're capitalized. The unfortunate thing that my lookup table gave me is that my IT department have gone and created all lowercase company names. So I've got a slight mismatch between the output of this, where it's the customer company here is lowercase. Actually, I want to try and match it with the uppercase. So what I'm going to do is combine it with my company rating. And I'll say I want to join that here, but instead of just a join between company ID and account name, which is the link here, what I'll have to do is edit that. So I can see I lied about the lack of scripting. This is the second time I'm going to show it. So instead of saying you need an ETL tool to be able to transform the data before Denodo can consume it, actually you don't need an ETL tool because we can do transformation on the fly here. So we've changed that to I'm going to match the ID with an uppercase account name here. So we'll save that. So that's my final view. So and we have a look at the output. I've got there's another array coming through here, so it's not flat data. I'm not particularly interested in the link to the individual record, so I'm going to remove that, and I'm not particularly interested in the company ID either, so we can remove those, and we'll save that. So we've built this data model. How do people consume this? So we've got this thing called single view. I'm going to expose this as a REST source. So I can go back here and say I want to publish that as a REST web service. By default, it's going to come out as HTML, but I can put a query string on the end to say, well, I want it as XML or JSON. We're going to keep it as HTML. And I can apply various things here as well, but we'll keep it simple. So we'll save that and deploy it. Deploy it as a particular user. Okay, that. And then I can see that data. So the built-in web container gives me access straight out of the box to be able to say, well, what's in this single view? So a quick view of the data. Further on from that, I can actually search against the data. So a little bit of data science, small d, small s, but allows me to quickly query the data before I go to my BI tool team and say, look, there's data. And in fact, if we go back a step, that's the URL we need to connect to. Okay. So there is data catalog, which we can't go into today, but data catalog is just a nicer way of accessing this data, trying queries, saving queries, sharing it with other users in a much more flexible approach. But what you've got out of the box is this ability to very quickly build something, reuse assets inside Denodo, build those models, share the models at any level with integrated security, and then see the output. And of course, all optimized. So thanks for watching, and that's the end of the demo.
Thank you, Chris. If you'd just like to unshare your screen so we can see everybody, that'd be grand. Hello again, Charles. Yeah. So before we go on to the questions, I just wanted to say for anybody who's missed the beginning of the presentation, or perhaps would like to go over some of the details in those presentations, perhaps go over the demo again. This session will be available on demand almost instantly on the BrightTalk platform, so you'll be able to go back in and watch any bits that you might want to go over again. Also, I'd like to highlight some attachments that we've got to this webinar. In the bottom left-hand corner, you can probably see an icon there with attachments. We've got some great resources in there from Denodo, some guides and access to a hands-on lab for anybody who wants to go a bit deeper into the topic. And there's the calendar of future Big Data London webinars in there as well. However, I'd like to ask some questions now, I guess, just to go a little bit further into this. I'll go with this one first. Seems like a good question. If I have a single view, what happens if two managers covering different departments look at the same view? I guess I'll fire that over to Charles would you like to have a go first with that?
Yeah, so that's a very relevant question. So the view allows access to the source data, but the view that the individual will get will depend on the role that they have. And so typically people's roles are defined in Active Directory, and those would have been linked to Denodo through LDAP without getting into too many details, so that the system understood if you had Department A manager and Department B manager, they could both look at a single view. Department A manager would only see the relevant information to Department A, and likewise for the colleagues. So the security is all built into that virtual layer. You can delegate to sources if you've got good policies down there and you want to use those, which is very, very important, particularly if you've got things like, relational sources which are well defined and so on. But you can imagine if you've got a spreadsheet as one of your sources, then clearly having the capability to obfuscate in the virtual layer is very important. So Denodo allows you to do both effectively, and so the two managers would only see their relevant sections. We had a very interesting case not so long ago where it was a police force wanted to be able to hide celebrities so that the information couldn't be exposed to the wider police force and sneak out into the press. Somehow these celebrities always seem to be the ones getting in trouble. I don't know why, but there you go. But that was an interesting use case.
Perfect. I was going to ask you about use cases, actually. I know you gave those two good examples, the reinsurance and the telecoms, and perhaps I'm answering my own question, but is there any industries which, particularly data virtualization is particularly good for, would you say? I mean, that could be, anyone could pick that up.
Well, should I take that one as well?
Go ahead. Yeah.
I mean, I think it's the pattern, really. It's anyone with large, disparate ranges of data sources. So certainly we see telco, financial services, manufacturing, retail, oil and gas. So it kind of, the answer is no, I suppose, because everyone's got so much data. But those, I would say, are the sort of 5 or 6 areas where we see probably the predominance and where you have greatest complexity. And particularly businesses where the data is their business. So if you think about financial products, it's largely about digital these days. The same with telco. Even with retail, it's supply chain optimization, warehouse management, EPOS, point of sale. We had one organization who wanted to look at the third-party websites to look at marketing information for haute couture, and they were looking at their competitors. They could scrape the information back through Denodo into their internal systems and look at their EPOS real time to understand if their competitors were doing something which was affecting their revenues that very day. And that meant marketing could be incredibly agile to needs. So any sector where timeliness and high volumes of data are important.
Yeah, and so size of company, it doesn't really matter about size of company, just amount of data really, in terms of, so I know the examples you gave were massive organizations, but smaller companies can benefit from data virtualization.
Absolutely, yes. Yeah,
perfect.
The other point to note, Andy, on that subject as well is you mentioned the size of the company, and I think it links into the ROI as well. So one of the things we do see is that regardless of the size of the company that obviously invest with the Denodo platform as well, they typically see an ROI within 6 months as well. So the platform itself has got a very fast ROI. And what we typically like to see when engaging with the clients, and particularly small businesses as well, is that we try and make the platform pay for itself within the period of time. Yes. Which is really exciting as well.
And one of the other questions around the platform, I'm glad you came onto that actually, Oliver, because you said one of the great benefits was agility. If there's somebody watching today who's thinking investing in something like this, is there any barriers that they need to think about, and is there barriers to overcome, and how do people typically overcome them? I'm happy for you to take it, Charles, or Chris to take it, in terms of kind of implementing this kind of solution.
The question that sometimes comes back is, I get the technology, that's fantastic. How do we organize ourselves? And that's an important question. Typically, the organizations that deploy fastest will have some sense of ownership or center of excellence or center of expertise, different names in different companies, but they will have somebody in charge, if you like, of the overall semantic model that they put into the virtual layer. They will typically combine that with departmental authorization, so that different departments who've got different needs have people in those areas who can have also development capabilities, but they're designing models which are specifically for their own departments. If you find that you then get multiple departments who have the same need, that model can be passed back to the center of excellence and held as a common data model for the whole business. And that's back exactly to your point about a single point of the truth or single view of the truth. But it allows, because if you do two extremes, you do either you give everything to the end users and you end up with the Wild West and skunk works and IT shadow works and so on, or you constrain it so much you end up with an IT bottleneck and it takes 2 months to get a dashboard changed. And so we find that balance is the optimal, and it empowers the users and the businesses without losing the IT control and governance.
Perfect. And I think this will be my last question. It's just a really simple question to you, actually, Chris. When will we be seeing the Denodo 8, kind of wider release? Because I got the impression you said it was a beta. When's that going to be coming out?
Yeah, so we're on beta 2 at the moment. So that should be the end of this month. So it should be next month that we go GA.
Perfect. Well, yeah. Well, it was great to have an advanced viewing of that, and I'm sure people appreciated that at home. So thank you very much. But unfortunately, I think we've run out of time. So we did have some more questions, but yeah, we're going to have to cap it there. Thank you very, very much to the guests. So I really enjoyed that. I thought that was a very thorough going over with data virtualization, and hopefully everybody enjoyed it at home. So it's goodbye from me and goodbye from all the guests. So we'll catch you at the next one. So thanks, guys, and see you soon. Thank you. Okay, bye-bye.
Thank you.
Thanks, everyone.